Hello guys, we meet yet again. So let us have more probability related questions, because this section, guys, we should really agree is a headache section, to be honest. The tough questions here are really tough, but they are doable. So let's just continue to work through this so that perhaps your confidence can grow. I've taken this paper from this practice paper, DBE 2023. I think it's a paper you will find on the DBE website. It's one for preparations, and I can assure you, if they choose this kind of questions, chances are these are the questions that may help you to align yourself with the level of the questions they are bringing for the finals. So please do check out that document. If you need one, I will give it to you if you WhatsApp me, because I have a hard copy on that one. Sorry, a PDF copy. But yeah, I don't know how to do these fancy things of creating a link and wara. The dude here is computer illiterate actually. So yeah, let's go. Now we're told in 10.1, a bag contains, so this one is the bag, that is our sample space, contains 7 yellow balls and 3 red balls. Go red nalo. No, go red. 3 red balls, and then we've got 2 blue balls. Okay. So can you see we've got a total of 12 balls. So be careful of totals. Total of 12 balls. Okay. Great. And then we're told here, a ball is chosen at random from the bag and not replaced. So this time we ain't replacing it, so that means it's not going back. So that's fine. And then a second ball is chosen. Okay, so that is fine. So first ball is taken but not replaced, and then the second ball is chosen, also definitely not replaced. So this suggests that these are going to be dependent events. If one occurs, it affects the probability of the others occurring. Okay, all right. So the question says, determine the probability that of the 2 balls chosen. Can you see? Of the 2 balls chosen, 1 ball is red and the other is blue, but they're not telling us the order in which they are occurring. They're not saying the first ball is red and the second ball is blue. They're just saying one of the balls is red and one of the balls is blue, and we took out 2 balls. You can see this is a formal question, so it's already telling us that 2 steps are more likely to be at play here. And again, it's one of those nasty questions. This is a higher grade question, because you have to figure out what tool is going to assist you here to get this question sorted and essentially work the problem. So we can see here, this is again a practice on tree diagrams that you need to master by now. So 10.1, we've got a possibility of 3 events from the sample space the first time around. So this means we've got this, and then we've got that, and we've got that. So don't get used to just having 2 possibilities, this or that. Sometimes they can be 3 like this one, and they can even be 4. So be very, very careful on this one. So remember, the ball could either be yellow, so we're going to use Y. It can either be red, we can use R. It can be blue, we can use B. Because we're just pulling from this bag. We can pull a yellow, we can pull a red, we can pull an R. We don't know. So let's just say we are pulling a yellow ball. So what would be the probability of pulling a yellow ball the first time around? Remember, there's how many yellow balls? There's 7. So we've got 7 options. Out of how many options? The total was 12 balls. So this is the first probability for Y. Now, what would be the probability of pulling a red ball? Because let's say we didn't get the yellow. Now we're getting the red ball instead. What would be the probability? There's 3 red balls. So we've got 3 out of 12 options. Can you see that? Say again, well, let's say those 2 did not happen, but B happened. So how many options did we have? There were 2 balls out of 12. So basically those are the first probabilities for those 3, because either one of those 3 is a possibility for the first draw. Okay, so now let's go to the second draw. The second draw here can go 3 ways. It could go this way, that way, or that way. So this could be still yellow, or it could be red, or it could be blue. The same will happen for this dude. It could go this way, that way, or that way. The second ball could be yellow, could be red, could be blue. And the same situation could still happen there, this way, and that way. So the second ball there could be yellow, could be red, could be blue. So can you see, this is quite a nice diagram to look at. Now let's look at those probabilities. Now we're going to say, since this happens, it will affect the second probabilities. If this one has happened, it affects how these others are going to happen, because these are dependent events. So out of 12 balls, we already drew 1, which has a probability of 7 over 12. Now how many balls do we have left? They are now 11, because we've already drawn that yellow ball. So we only have 11 now. But these others have not been affected because they did not happen already. So we're not really talking about this side as yet. So we're not talking about this side for now. We are just focusing on that side. So leave this one for later, okay? Focusing there. So we're saying perhaps we drew a yellow ball the first time around, and that's it. We didn't draw any other balls. Now what's the probability of drawing a yellow again? Remember, out of 7 we took 1. So we only have 6 yellow balls left. Out of how many? They are now 11, because we are missing 1 ball. Okay, that would be the probability for drawing the yellow ball the second time around, if the first time around it was a yellow ball. Then we come here and say, look, what if this yellow ball did not happen actually? The second ball came out red. How many red balls did we have? They are still intact, so it would be 3 over the total, which is now 11. Why? Because we've already drawn a yellow ball the first time around, and we did not replace it. Okay, let's look at the second scenario. Let's say, well, we did not draw the yellow, and we also did not draw the red ball the second time around, but it was blue. How many options do we have for blue? There were still 2 blue balls, because we had not spoken about drawing any blue ball or red ball the first time around. The first time around was a yellow ball. So that means we only lost a yellow ball out of this pool. So now if we drew a blue ball the second time around, there were 2 blue balls out of now 11, because we're already missing 1 ball out of those 12. So those are the probabilities for that portion. And then we come here and say, look, we are not talking about this or this at this point. We are focusing on the next one here. Okay. So let's focus on this one. Let's say the first ball was rather red. Now what is the probability of drawing a yellow ball the second time around? Remember, if we're choosing these red balls, it means there was nothing that happened to the yellow. So there were 7 yellow balls. There were 7 yellow balls over, because now we already took out a red. They were 12, so we will have 7 over 11. And then if we are drawing the red ball instead, we didn't get the yellow. We just got the red the second time around again. There were only 3 red balls. So we took 1, so there would be 2 over 11. Okay. So let's say, well, we didn't draw the yellow, we didn't draw the red the second time around. We drew a red the first time, and we're drawing a blue the second time around. How many blue balls did we have there? There were 2 over 11. Okay, so those are the probabilities. I don't know if you guys can see that. It looks a bit too small. So this is 2 over 11. Okay, again, this thing takes a bit of time, guys, but I know you guys are fast, so I'm just explaining, which is what takes a bit of time. Now let's say none of these two scenarios happened. We instead drew the first ball was blue and now the second ball is yellow. What's the probability? Again, if nothing happened except a blue ball the first time around, it means we still have 7 yellow balls out of 11 because we're missing just one blue ball. And then here, if we choose the red here, there were how many options for red balls? There were 3 initially. So we're going to have 3 over 11 because we would say that that yellow didn't happen. Instead, a red happened after the blue. And then we come again and say, look, none of those two happened. Instead, we got a blue and then the second ball was blue. So how many blue balls did we have? There are 2 out of 11 because we are missing just one ball. So this is how you do this tree diagram. At this point, it doesn't really help to worry about outcomes. If you're not given that instruction, just abandon that idea. We just wanted this as a tool to assist us. Now the question says, determine the probability that the 2 balls chosen, one is red, right, and the other is blue. But they're not telling you whether the first ball is red and the second ball is blue. So that means any combinations of red and blue are acceptable. So where do we see this? Now, it means the yellow is not to be considered. That arm with yellow, we're not interested because it means it's out. So forget about that arm for yellow. So what we want to focus on is these ones. Now it means the first ball could be red and then it can go on to a blue because if one was red, the other one should be blue. Okay? Or the first ball could be blue and then the second ball could be red. So those are the arms that we need to focus on. So it's either the first ball is red, the second ball is blue, or the first ball was blue and the second ball was red. But any combination of one red ball and a blue ball is what we accept. So that means we'll just sort out those two probabilities. And we know now that, okay, the probability of the event, I just don't complicate my life here, is going to be either that arm, and when we're going up the arms, we multiply. So it's going to be either the probability of red followed by blue, or, now an or in maths is a plus, the probability of first getting a blue ball and then a red ball. So that is how we calculate this. Okay, so now let's deal with this one. What would be this probability? So up the arms we multiply. So this is going to be 3 over 12 times 2 over 11. We close that bracket plus this branch here. It's going to be 2 over 12 times 3 over 11. Okay, so once you get here, you can just put it in the calculator and the answer is going to be 1 over 11. Now here you are at liberty to do your own thing because they never represented any probabilities in percentage or decimal or fraction. So you just do whatever you will here. You can convert it to a percentage, you can convert it to a decimal, or you leave it as a fraction, because those are the 3 ways we can express a probability. So can you see this question is 2 steps, and essentially technically, and you know almost that, yeah, you throw all the punches that you can, folks, and you do it. And you can see that essentially drawing the tree diagram is your first mark. Okay, the tree diagram is the first mark, and adding those probabilities in each arm, of course it's complicated, but who cares, you're getting your second mark. The third mark is actually on these substitutions over here, and the fourth mark is the answer. Great, so let's move on, guys. So 1 tool down, and I'm sure now you've gotten the hang of how to use these. So let's go on to 10.2. 10.2 says, learners at a hostel may choose a meal and a drink for lunch. Okay, so we've got a meal and we've got a drink for lunch. So that means this is our lunch time. So during lunch we can either eat a meal. In fact, we will eat a meal and a drink of our choice. Now we're told here their selections on a certain day were recorded and shown in the partially completed table. So this is what we call a two-way contingency table. It's a two-way contingency tafel. I don't know what is way. Is it weg? Anyway, let's not even attempt to be silly. Now, let's see. Now, totals are important, folks. And this grand total right here is our clue that we actually have 250 learners in this hostel, because that's the grand total. Okay. All right. Okay. But also this total right here is critical to consider, because as well it gives us an idea of what is going on. Okay, all right, okay. So we are told here, well, it doesn't look like we are going to be able to sort this out just right or just yet. Let's see. It says now the probability of a learner choosing a fruit juice and a sandwich. Can you see? Probability of a learner choosing a fruit juice and a sandwich on that day was 0.48. Very important. So look, fruit juice and a sandwich. So what is that telling us? These two things are happening together. So this is giving us a probability here. But now it doesn't give us A for sure, but we know that we've got a total here. So the number over the total. So this probability here of a fruit juice intersect a sandwich, which is going to be S, is going to be what they're giving us, which is 0.48. Now this means we just need to determine this in principle now. How do we do a probability? We take the number over the grand total. Is it not so? Yes, because all of these things are over the grand total. So let's see. This is going to be essentially A over 250 is equal to this probability 0.48 over 1. You just cross multiply there. We can get A as 250 multiplied by that probability 0.48. And let's see what it gets us. So this is again not a very easy question. It's yet another higher order question. Maybe we can say it's a higher order. It's not really higher grade, but higher order. It causes a few issues, a few headaches. I man, HS yantongo. Higher order. So this is going to be 250 times this probability 0.48. This gives us 120 learners. So that means A is 120 learners. So these questions, they always give you information, folks, to be able to do these things, but you need to be able to understand how to do this. Now that we have 120 and this is 200, so that means what must we add to 120 to get to 200, because that total should match. So we can simply just say 200 minus 120. It gives us 80. So this means here there's 80 people. This is 80 people. It's too thick. Okay, nice. Now we've got one part sorted. But now remember, if we've got 200 here and we've got 250 here, what should be here? It's 50. Because these totals, you should be able to add to 250 horizontally, and you should be able to add to 250 vertically. But now this helps us to find that one, because on that column we should add to 50. So what should we have here? It should be 20, because 30 plus 20 should give us a 50. Then we can say 80 plus 20 is 100. If that's the case, 250 minus 100 is going to be what? Is going to be 150. Okay. So now we've completed our table. So you work with the totals, but you could see here there was no way you could get anywhere if you didn't solve A first, and that was given by this statement. So I cannot overly emphasize, guys, the doctor's approach or the Mgosi approach, umugosi, because now ungawusebenzisa as the idea behind how you work things out. So here it says calculate the number of learners who chose fruit juice and a sandwich for lunch that day. We just answered that. So it means we must find the value of A. What was the number there? We found that they are 120. I don't know what happened there. I got 120. Okay. So they are 120, but now we have to show this calculation. So all we can say, the number of learners is going to be equal to, you can just say 250, the total, multiplied by the probability, which is 0.48, because you already know that that is what it's going to be. Or if you don't want to be silly, you want to go step by step, we know that we are given that probability of, for example, a fruit juice and a sandwich is given by 0.48. Okay, let's just do it nicely. This implies the probability of F and S is going to be those number of students at A. So this is basically going to be A over the total of the students we've got, which is going to be 250, is going to be equal to 0.48 over 1, since we're dealing with fractions, and then we cross multiply here. We can say therefore A is going to be 250 multiplied by 0.48, and that should give us the number of students, which is going to be 250 times 0.48. That gives us 120 learners. Learners, I andazi writing yami means of elibe ngconywane ibe means of cimela nje. Mhlambe sendinwe kakhulu. Hayi kodwa ndinwanga iyaniqhela nje. Inamaxesha nje uniqhela kabi. And sekufanele ndike ndenze something ngayo ngoku, because seyandihlanyisa. Ndike ngoku ndiligeza laseMpuma Koloni ke mna ke. Hlangana nento ezingenangqondo. Asendiphambene ndibaligeza. Ndiyaraka. Wakweva xa kuthiwa ndiyaraka. Yes, must rag, if that is Afrikaans. It sounds like Afrikaans, but yeah. Anyway, I never got the chance to learn the language properly, so let's not even break it before I start making people uncomfortable. So that question is sorted, guys, and as you can see, you're just getting the answer. All your shenanigans, are not interested. But remember, the question said calculate. Calculate. So don't start doing your own things. If it says calculate, please show that calculation, even though the answer is where the mark is, but we still want to see that calculation. Okay, now 10.2.2 says, is the choice of fruit juice independent of the other choice? Sorry, is the choice of fruit juice independent of the choice of sandwich? Okay. Now this means we need to prove the product rule here. We're just going to prove the product. I'm sorry guys, it's too thick and I don't know how to make it thin. we have to prove the product, the P rule. Ngoba sengicaphukile, senginqaphile. Se ke kgenne jwala, ha ke sa batla ho utlwa. Hobaneng e batla ho ntshwarisa hlooho ntwe. And hey, ha ke batle nna ho tshwara ke hlooho. Hobaneng ke tlo ba eng? Ha ke sa batla le ho bua hore e tlo mfetola ke be eng. Ha re itlwele hona mono bana beso. Ha re tswelleng pele. It says now, is the choice of fruit juice, which is this guy here, independent of the choice of a sandwich for lunch? So this means we need to prove whether P of F and S, is it going to be equal to the probability of just fruit juice chosen multiplied by the probability of the sandwich. So we've got to prove this, because if we can prove this, then we are sorted. But we know already what this is, right? We know that this one is already given to us, because this probability of Elena choosing fruit juice and a sandwich was just that A, which is 0.48. So we already have it. All we have to do is to find what is the probability of choosing fruit juice. Now all you do, you're going to look how many learners took fruit juice as a choice of drink. It's A, B there. So all of these guys added up to 150. So this is going to be 150 over, what is the total? Again, it's 150 students out of 250. Then we're going to say multiply by the probability of choosing a sandwich. This one we will find the total in the vertical column. And how many were they who chose a sandwich? There were 200 in total. So we're going to take that 200, and out of how many students? 250. Maske siboneni ke ngokuba siyalingana na ezi zinto. Kuba zilingane hayike imbi ke ngoku. 150 divide by 150 divide by 250 times 200 divided by 250. The answer is voila, is 0.48. So that means the probability of a fruit drink and a sandwich is essentially equal to the probability of just fruit juice choice multiplied by the probability of a sandwich choice. And if these two are equal, it means the product rule is proven correct, and therefore these two are definitely independent. We can say, therefore, this means the probability of P F intersect S is equal to the probability of F multiplied by the probability of S. Therefore, we can safely say now the choice of fruit juice is independent of the choice of a sandwich. All right, since the probability of F, which is fruit juice and a sandwich, is equal to the probability of fruit juice multiplied by the probability of a sandwich choice. But maybe we don't need the statement here. We need it at the end, because they can see it, man. Sometimes these things are cumbersome. There's no best way to do it, but you can just do your best. The best is yours, because you are not the examiner, guys. You won't know what they were thinking. You won't know what they want, but if you can be elaborate and someone can follow your pattern of thought, they are happy. So you can see this was not quite obvious. It had to involve a few calculations. They can still make this one a higher grade question. Remember, this is just a higher order, but I could convert it to a higher grade question by not asking 10.1 and just ask 10.2 instead. Then you just have to fiddle your way around. Okay. All right. So how many marks were we taking here? Obviously, this is important. Okay, maybe let's just say this is important. And this calculation is important. And this conclusion, whether a convincing reason. I mean, we wouldn't really mark you for that 0.48 for that one because it was given. So this is how I believe these 4 marks should be taken. And I don't know if there were any more questions that got cut because I just took this as it was sent to me by my girl. Anyway, guys, I hope you guys are enjoying these videos and you are learning from them, because the most important thing is to learn from them so that you can gain independence in solving these kinds of questions so that you can get your marks that you desire. Otherwise, if you're just watching for fun, I'll be concerned, because you would be trying to tell me that I'm wasting my time, and I don't believe I am. So I wish you guys luck. Please continue practicing and use these tools in probabilities. Know how to construct a Venn diagram and know how to work with it and know how to deal with it when it's given to you. I think I've done enough questions that highlight how a Venn diagram can be used. Know how to use a tree diagram. I think I've done enough examples also in the past papers that I put on the channel. So you should be able to learn all the thought process that you go through and the simple arithmetic calculations you have to perform, and essentially getting around the question, which may be difficult, it may be challenging, it may be overwhelming, but if you've got the first steps right of analyzing, understanding, identifying the tool that can help you, and if you do those two well, chances are you may just make a mistake by not being careful. Otherwise, you should actually get full marks, you know. So know the tree diagram very well. It's so very common with the higher grade questions in this section, or the higher order questions in this section. Then know also how to use the two-way contingency tables, because they may bring them instead. So whatever is thrown at you guys, you've got tools, and there's no excuse in not knowing how to construct these things, because they can throw you a sentence with a lot of information. You need to be able to construct a two-way contingency table, meaning you must be able to do this table given some pieces of information. And you will already see, if you get something that talks about 2 choices of food, sandwich or pasta, and then you've got 2 choices of what you call drinks, which is bottled water, you can even do a tree diagram for this thing. You don't have to really think of this thing two-way contingency table. But sometimes when they give you numbers like this and you don't have other areas they are missing, then you are almost at a bit of a situation. But what they can do, if they want you to succeed, they will volunteer this 250 as a total. Then you can decide whether you want to do the two-way contingency table, which you should be able to construct and use, or you want to do a tree diagram. You can still use that. It will work. Remember, a tree diagram works for both independent events and dependent events. So a two-way contingency table can also do the same sometimes. Anyway, guys, I hope you enjoy this thing and you're going to keep practicing. Otherwise, guys, I wish you luck on your attempts. So my next 2 questions that I will do some on functions, just to highlight a few issues on functions that you are probably going to meet with, and to essentially seal my revision for you for paper 1. And then from here on, we will move on to paper 2 when you are about to face it. And I will throw in at random in between some chemistry videos so that I don't have to give you too much work when you're almost facing the dangerous time. Okay guys, this video is getting out of hand. I didn't want it to even get to 30, so I've already spent 5 more minutes beyond my target time. Otherwise guys, wish you luck, and remember, believe in yourselves. Do these things. Look, I've done them, but take this question, even though you've seen how I do it. See if you can see what to do. Will you remember what you saw I did, and you do it? Because as you do this yourself, I can assure you, there will be a new realization of something. Whether you have been missing the idea and now you got it right, or whether there is another possibility that you can actually venture into. Like I'm saying, try drawing a tree diagram for this information we have here and see how it goes. Will it be able to assist or not? It should, you know? Yeah. So anyway, guys, goodbye. I will see you when I see you. Good night.